Welcome back to All This Math. This is Professor Parker, and for today's video, I just felt like doing some multiplication. I felt like using the lattice method to multiply two decimals. So we got 0.34 times 0.56. Another way to think of that is, what is 34 hundredths of, because multiplication means the word of can be used to represent multiplication. So what's 34 hundredths of 56 hundredths? So 56 hundredths is like a little bit more than half. 0.34 is a slightly more than 1/3, right? It's important to understand the equivalencies between fractions and decimals, right? So you can often kind of like estimate what the answer is going to end up being, right? So basically we're saying, this is close to saying, I should say, what's 1/3 of a half? So 1/3 of a half. So imagine you have 50 cents. Take 50 cents divided by 3. That's like 17 cents, because 51 divided by 3 is 17. Some of y'all ain't know 51 is not a prime number. 51 is not a prime number. 51 is a composite number. So 1/3 of 50 is close to 17, since 51 divided by 3 is 17. So that should be close to the answer that we end up getting when we actually do the math. Now we're going to use the lattice method, because I felt like doing the lattice method. So I said, let me do a little video using the lattice method, right? I got some other videos on the channel where I show how to use the lattice method, but let me do another one, right? And this is actually an example that I posted on my Facebook page, because, if you follow me on Facebook, you know that I post the little math problems in my, the notes, my Facebook notes, right? So you probably seen this problem if you have watched it recently, so, or at least near the time of me recording this video, I should say. All right, so lattice method. Well, what is a lattice? A lattice is basically a crisscross formation of rectangles and squares. That's what a lattice is, right? You may see lattices in some type of decorative fencing around a house or around a garden, or, like maybe a privacy fence, where it's got like vertical rows of rectangles, and it's also got horizontal rows of rectangles, right? But then you have different type of lattices. You got lattices in chemistry, dealing with like, molecular bonds and how they're shaped and all that. And it gets complex and it gets convoluted. It's a lot of different types of lattices also. But the type of lattice we're going to deal with is basically the more traditional. It's like an array. You got columns and you got rows, right? So we got columns and we got rows. All right. So what I'm going to do is I'm going to do a 2x2 or a 2x2 array, basically. And why am I doing a 2x2? Because I need 4 boxes. 4 boxes. Now, how do I know I need 4 boxes? Because I got 1, 2, 3, 4 digits. All right. Now, when I first tried to do this on paper, using the lattice method, I was a little confused. I confused myself, because I was like, wait a minute, do I got to put the decimals with the digits when I break the digits down? How do I do that? Right. But then I said, oh, all I got to do is I could kind of treat it like I'm using the standard algorithm for multiplication. When you multiply decimals, I can actually act like these are just whole numbers, like 34 times 56. And then I can just apply the decimal to the final product, right? So I'm going to do the same thing using the lattice method. So again, I'm not going to worry about the decimals when I actually set the problem up. But if you haven't ever used the lattice method, this is how it goes. Now, like I said, I'm going to draw what we call a lattice. It's a lattice, right? Because a lattice is like a crisscross array of rectangles. So I'm going to do this first, right? Draw like a box. And I got my 2 columns, right? And then I draw another horizontal line, and I got my 2 rows, right? Now, again, why do I need 4 boxes? I need 4 boxes because the number of boxes that I have inside of my larger rectangle should be equivalent to the total number of digits that I have, right? So I got 1, 2, 3, 4. All right. The total number of digits that I have to write to represent these 2 numbers. All right. Now, what am I going to do with that 0.34? Remember, I said I'm going to treat it like it's a whole number, 34. So I'm going to put my tag sticking up. I hate when that happens. Hold on for a second. I know some of y'all watching this can relate. Y'all probably hate that too. So yeah, so anyway, I'm gonna treat this 0.34 like it's a whole number. So I'm gonna put the 3 from the, if it was a whole number, that 3 would be in the tens place, and this 4 would be in the ones place. And I'll put that right there. Then the 56 is gonna be written vertically along the right side. So I put the 5 right here and the 6 right here. But another thing I do is I basically cut these rectangles into triangles by drawing diagonal lines that are going down to the left. So these lines, if they were graphed on a coordinate plane, they would have a positive slope because they go up to the right or down to the left. So I got 1, 2, 3. All right. All right. So look, I got my 1 row, 2 rows, 3 rows, 4 rows, 4 diagonal rows. All right. Now this is the lattice method. And now what we do is we're going to treat it like it's a multiplication table, right? The table of values that we should all have memorized, at least up to 12 times 12. You can go up to 15 times 15, 20 times 20, 25 times 25. The sky's the limit, right? But we should at a minimum have our multiplication facts memorized as a consequence of doing a lot of practice, at least up to 12 times 12. All right, so this is what we're going to do. I'm going to start here. I'm going to do 4 times 5. What is 4 times 5? 4 times 5 is 20. So where do I put the 2? Where do I put the 0? I put the 2 in the upper triangle, and I put the 0 in the lower triangle. So that's 20. All right, take a look at that. Look how that's written, right? 4 times 5. Where did 20 come from? It came from 4 times 5. They meet in this square. The tens place digit goes here. The ones place digit goes here. Then I'm going to do 4 times 6. Now, does it matter what order I do the multiplication in? It doesn't matter. I just said I'm going to do 4 times 6 now. I could have did 3 times 6 next. I could have did 3 times 5 next. It don't matter. It don't make a difference, right? I could have did 3 times 6 next. It don't matter, right? But I'm going to do 4 times 6. And 4 times 6, because I know my multiplication facts, I know that's 24. So I'm going to put the 2 right here, and I'm going to put the 4 right there, right? Then 3 times 5. What is 3 times 5? The product of 3 times 5 is 15. So then I'm going to put the 1 right here, and I'm going to put the 5 right there. Then I'm going to do 3 times the 6. 3 times the 6. Again, multiplication facts. 3 times 6 is 18. So I'm going to put the 1 right here, and I'm going to put the 8 right there. Now, I'm finished with the multiplication part of this. Now it's time to do the addition. We're going to add the rows, starting with the bottom row. We don't start at the top row. We don't start in the middle rows. We start at the bottom row. Not the top, not the middle. We start at the bottom. So this is a 4. There's nothing else to add to 4. So I just write the 4 outside of the lattice. All right, that's the 4. Then I go to this row, this diagonal. I got a 0 plus 2 plus 8. 0 plus 2 is 2. 2 plus 8 is 10. Now, this is similar to the traditional algorithm for multiplication because now I'm doing addition, right? And I'm going to have to carry, right? So this is 10, right? So I'm going to put the 0 right here. I'm going to carry the 1 to the next row. Notice what I just did. Where did this 1 come from? It came from the fact that 0 plus 2 plus 8 is 10. So I put the 0 from the 1's place right here. I carry the 1, put it up there. All right, now I'm going to add these numbers in this row. 1 plus 2 is 3. 3 plus 5 is 8. 8 plus 1 is 9. My sum is 9. So that goes right here. Right, then I got 1 by itself, just like I have 4 by itself. 4 by itself just gives me 4. Because it's basically like I'm saying 1 plus nothing. It's nothing else to add it to. So I'm doing 1 plus nothing. Right? So that's 1 right there. All right. Now, when we look on the outside of the lattice, the sums of each of these diagonal rows, these numbers consist of, or I should say our answer consists of these numbers, right, going counterclockwise. Counterclockwise. Sometimes I get clockwise and counterclockwise confused. I'm too old for that, but, I still get it confused sometimes. This is counterclockwise, right? Yeah, because clockwise is this way. Yeah, this is counterclockwise. All right, so 1904. But the answer is not 1,904. Right? If these were not decimals, this product would be 1,904. That's what it would be. But these are not whole numbers. These are decimals. So now what do we do when we calculate a product using the standard algorithm for multiplication when we're multiplying decimals? What we do is we count up how many digits are behind the decimal point in each factor, because each of these numbers are factors. You multiply factors together to get a product or a multiple. So I got 2 digits after this decimal point. I got 2 digits after this decimal point for a total of 4 digits. So I got 4 digits after decimal points, 4 digits after decimal points. So what does that mean? I take that information and I say, oh, all right, I should add 4 digits after a decimal point in my final product. So I got 1, 2, 3, 4. I should have 4 digits after the decimal point of my final product. So that means that decimal point should go right there. So that means that the final answer should be 0.1904. 0.1904. All right. And that makes sense because, like we said from the beginning, this is very close to 1/3. That's what this is. Very close to 1/3. This is a little more than a half, not very close to a half, but a little more than a half. So a third of a half would have been 17, right? Or 0.17, right? This is 0.19. You know why that's bigger than 0.17? Because 0.56 is bigger than 1/2, right? Plus, this is more than 1/3. So our answer is reasonable. We already expected it to be close to 0.17. 0.1904 is close to 0.1700, right? Because 0.17 is the same thing as 0.1700. So you want to be able to manipulate numbers and kind of play around with numbers to kind of get an idea of, what you can expect the answer to be once you actually do all the math. You know what I'm saying? So at any rate, that's the lattice method. And that's using the lattice method with decimals. All right. So that's that. Now go get some practice, make up some problems, make up some of your own problems where you can use the lattice method with decimals, make up some of your own decimals. All right. Shout out to the ancestor, Frantz Fanon. You see his name right here, Fanon. You know what I'm saying? Frantz Fanon, great scholar, Pan-Africanist, psychiatrist, revolutionary, very interested, very committed to the liberation of African people and really all people worldwide. Definitely check his books out. Wretched of the Earth, Black Skin, White Masks, Toward the African Revolution, A Dying Colonialism, you know what I'm saying? Plus a lot of other of his writings and also biographies. There have been many biographies written about him and also many compilations of a lot of his writings. Check him out. Get familiar. All right. I'll see you on the next video. Peace.